All right, so a couple homework questions from the exam to review, and we have a product rule to do, and we have a quotient rule. So let me write this down so I get it right. Okay. And whiteboard, please. So we want the derivative with respect to x of the product of t squared plus 4t plus 8 times 4t squared plus 3. See if I copied that right. Yep, looks right. All right, so product rule says take the derivative of the first function. So remember, product rule says f prime times g plus f times g prime. So this is my f here, and this is my g. So I get the derivative of the first would be 2t plus 4, and then I multiply that by the second function. I don't mess with that yet. And then I leave the first function alone, and I multiply by the derivative of the second function. So 2 times 4 is 8t, and then derivative of 3 is 0. So I get that. And then we want to clean this up algebraically. So this would get you maybe half credit on the test. You got to do some algebra to clean it up. So we want to distribute and clean it up. So 4 times 2 is 8, t squared, t cubed, I lied, plus 4t, let's see, 16t squared plus 6t plus 12. And then over here, I have plus 8t cubed plus 32, oh no, yeah, 32t squared plus 64, oops, that's not a 4, t. All right, does that look right? 8, 32, 64, 12, 6, 16, and 8. Yep, those look good. And then find your like terms. So we've got some cubes. So we get 16t cubed plus we got some squares, 48t squared, and we have some t's, 70t, and then the 12's just chilling. So that'd be the best possible answer right there. All right, quotient rule. Oh, good, we got another couple questions. Thank you. All right, so 4 minus x squared over 7 plus x squared. And although the numerator factors, I don't think that helps us because nothing cancels in the denominator. So I would just apply the quotient rule. I don't see any clever algebra to do there, but it's always worth thinking about that with the quotient rule because it's a bit more complicated. Can you make the function simpler to take the derivative of? I don't think so. So quotient rule says you've got your numerator function f, your denominator g, it's f prime g minus f g prime all over g squared. So the important things to remember is the denominator gets squared. It's kind of like the product rule that its subtraction has to go with the derivative of the denominator. So the numerator's derivative is negative 2x times the denominator 7 plus x squared, and then minus the numerator's left alone times the derivative of the denominator, which is just 2x. And all of that is over 7 plus x squared, squared. And it's almost never worth multiplying out the denominator. So always leave the denominator in factored form. Trick back from your intermediate algebra days. So we got to do our distribution here. Negative 14x minus 2x cubed. And then here we have to distribute the minus and we have to distribute the 2x. So I'm going to distribute a minus 2x there. So minus 8x. And then we have negative times a negative would be plus 2x cubed. And all of that is over. And we want to keep going until we think we can't clean it up anymore. So we want to use less ink than we started with. All right, so what do we get? We get, oh, the cubes cancel. That's nice. Do they really? Yeah, they do seem to. Okay, and so then we have negative 14 minus 8, which is what? Negative 22x over 7 plus x squared squared. And how do you check that? Well, you could whip something out like the derivative calculator if you wanted to, or you could find a tangent line using this as your slope function. So this is what I think f prime of x is. There. All right, got a bunch more questions in the chat. Let me take a look there. Okay. All right, so we just did 5, 6, and it sounds like those helped. And then we have 16, 17, all right, let me write this down. 16, 17, 22, 25, and 30. Good job asking questions. So next on the list is 16. What do we got? So here I have the chain rule going on because we have a function within a function there. So I'm going to see if my screenshot works. Let me try blowing this up. Yes, nice. Okay. So what is f prime? Oh, another question popped up there. 12. So again, I have a function within a function, and the inner function is the quotient rule. So this is the chain rule going on. So my outer function, so whenever I do the chain rule, I try to make a note to myself. What is the outer function? The outer function is whatever to the 6th power. And then the inner function is that x plus 6 over x plus 2. And there's really not much we can do to clean this up, kind of like the last one we had. You could do long division on it. That might get you out of the quotient rule, but maybe not. So let's see. Chain rule says take the derivative of the outer function. So for my f prime here, right, this is f of x. The outer function is whatever to the 6th power. Chain rule says leave the inside function alone for a moment. So that just goes there. And then multiply by the derivative of the inner function. Okay, so the inner function is where the quotient rule applies. So this is my numerator, right, my f, and this is my g. So I need my f prime g minus fg prime all over g squared. So a lot of times when I'm doing these complicated ones, I just write some notes to myself to make sure I get it right. So derivative of x plus 6 is 1 times the denominator, x plus 2, minus the derivative of the denominator is 1 times the numerator, x plus 6, all over the denominator squared. So that would be x plus 2 squared. And then let's see if this cleans up. What do we got? So we still have that x plus 6 over x plus 2 to the 6th. And then here, I'm going to get, let's see, let's write it out. X plus 2, and then distributing -1 minus x minus 6. So I'm going to have a -4 in the numerator. So I get times -4 over x plus 2 to the second power. And we could distribute that 6th power 2 and clean this up a little bit. Let's see if it uses any less ink. Let me get rid of that for a sec. So we could say that's x plus 6 to the 6th over x plus 2 to the 6th times -4 over x plus 2 squared. And then bring the denominators together. This would be negative, and the numerators, -4 times x plus 6 to the 6th over x plus 2 to the 8th. And so then which one, let's see if my highlighter works, uses less ink? This one here or this one here? And that was my intermediate step. They're pretty darn close. I think the last one uses a tiny bit less ink. So maybe if the first one weighed in at like 20 milligrams, the second one would be like 19 milligrams in ink weight. All right, moving on. So I would accept either this answer or that answer there. 16, 17, 12 is in there now. Let's back up and see what 12 looks like. Okay, square root, another chain rule, nice. Let's do that one, 4x squared plus 6. So what is the derivative with respect to x of the square root of 4x squared plus 6? And so again, I have to identify inner and outer functions here for the derivative because this is complicated. So the outer is for sure the square root. And then the inner is 4x squared plus 6. So derivative of a square root function, hopefully you have that one memorized, is 1 over twice the square root. And inside, we happen to have a 4x squared plus 6. So chain rule says take the derivative of the outer function, leave the inside alone, whatever was in there. And then multiply that by the derivative of the inner. So that's times, 2 times 4 is 8. X, derivative of 6 is 0, so I got that right there. And this cleans up a tiny little bit. The 2 goes into the 8, so we're going to get a 4x over the square root of 4x squared plus 6. And again, you could rationalize the denominator, but I think that's worthless because it uses way more ink to come up with the answer. So I would stop right here. But if you want, rationalize the denominator to prove to yourself it doesn't really use less ink. So the only way to know if something simplifies is to try some algebra and see what happens, weigh the results. Next, number 17. All right, here we have a sine squared. And they're giving us a hint that the chain rule applies twice here, and that we have an inner, an outer, and a middle function. All right, so I'm going to snapshot that, blow it up again. So let's see, let's break this down. So the recommendation below is to say, hey, when you square a sine, that can be written a little bit different. So I'm going to write it how they suggest would be -4 times parentheses the sine of -5x to the 8th. And we did one like this in class last week, and then put the square out here. So this is shorthand notation for this right here. So it's important to realize that so you can identify what's the inner. So if somebody gives me an x value, the first thing I'm going to do is I'm going to find the 8th power and multiply by -5. So that's my inner function. So inner, outer, and middle come from the order of operations. All right, once I calculate negative 5x to the 8th, then I take the sine of that. So the sine is next in line. So we've got a middle function. Sine of whatever. And then after I calculate the sine, I'm going to raise it to the second power. So this is my outer. So that would be just whatever squared. And the -4, that's just a constant multiple that just hangs on. So we can kind of just pull it out and ignore it. So y prime, if this is y right here, according to the chain rule, is the derivative of the outer times the derivative of the middle times the derivative of the inner. So all I have to do is get those right. So let's see, derivative of the outer function, the derivative of a square is twice whatever you squared. And then back up here, what was being squared, but the sine of negative 5x plus 8. So that goes back in here. Or negative 5x to the 8th, sorry. All right, so that's the derivative of the outer, right? Take the derivative of a square, 2 times whatever the base is. Chain rule says, okay, multiply by the derivative of the middle, derivative of sine is cosine. And chain rule says, whatever was in there, just leave it for a moment. So negative 5x to the 8th stays right there. And then, so that's the derivative of the middle, right? Cosine of whatever was inside. And then last, derivative of the inner, so parentheses, 5 times 8 is 40, so negative 40 x to the power 7. Okay. And put it all together. So negative 40 times 2, I get a negative 80. And then might as well bring the x to the 7th out front. So I got that, and I've got that, and I've got that, and then sine times cosine. So then I have the sine of negative 5x to the 8th times the cosine of negative 5x to the 8th. And we could apply double angle formula to that if we wanted to. I think we did that before. But I think this is a sufficiently good answer right there, but it does simplify if you notice that the sine of 2 theta is equal to twice the sine of theta cosine of theta. And so in this case, theta would be the negative 5x to the 8th. So I could take that a little farther by taking the 2 out of the 80. So if I thought about this as negative 40 x to the 7th times 2 sine cosine, and we did like one like this last week, I think it was, this right here is this identity. So then that's going to become negative 40 x squared times the sine of twice my theta, which is negative 5 x to the 8th. So that would be negative 10 x to the 8th. Yeah, it loses less ink. Yeah, so I think if you took it this much farther, I'd probably give you a bonus and say, whoa, that's awesome, good job. But I would be happy if you got it this far there. Okay, the negative 4, did I miss something? Oh shit, right, the negative 4 was hanging outside. Oh my gosh. Thank you, Cole and Evan and Cole and whoever else jumped in on that. Yeah, oops, I forgot it's negative 4 times all of this stuff. Negative 4 times, negative 4 times. So then with that, negative times a negative is a positive, 4 times 4 is 16. So then the two possible answers would be 160 x squared. No, 4 times 8, 320 for the first one. Let's see, 320 x to the 7th. There we go, sine of negative 5 x to the 8th cosine of -5 x to the 8th. And it turns out there is a way to deal with these negatives inside. We played with that before. I'm not going to do that right now. So that'd be one possible answer. And then the other one would be 160 x to the, oops, that should be x to the 7th, not squared. X to the 7th sine of -10 x to the 8th. Okay, so that'd be the other acceptable answer here. Yeah, thank you for pointing out my algebra errors. So remember, on a test, write everything down so you can look back at it and say, did I make any little stupid errors like multiplying wrong or? All right, let's see. Where are we? Questions. All right, let's go back. Don't think we went back to 12 yet, did we? Oh yeah, we did that one. So 17, 22, 25. 22. All right, implicit differentiation on an ellipse. Cool. So we could graph this one to check it too, to see if we actually found the slope. So I think I need to copy all of this. This is a cool question. Screen shot. All right, got it. And this is number 22 in the review. So this is the graph of an ellipse, if you didn't recognize it, and we'll see that in a minute when we graph it. And the form of ellipse, by the way, is x over a squared, x squared over a squared plus y squared over b squared. And these a's and b's form the axis of the ellipse. So then, like over here would be -a, +a, -b, +b, and then that ellipse would flow through here. Oop, hard to draw today. Okay, so implicit differentiation. So we want to take the derivative with respect to x of each side. So x squared over 81 plus y squared over 16 equals the derivative of 1. Right, so implicit differentiation means you have an equation, you didn't solve for y, or you couldn't solve for y, and you take the derivative of each side and see what happens. So derivative of x squared over 81, dividing by 81 is like multiplying by 1 over 81, so that just gets carried along. So I'm going to get 2 over 81 times x. And then here, pretty similar, the 1/16 gets carried along as a multiple, so then I'll get plus 2/16 y. And then with implicit differentiation, we always assume y is a function of x. Chain rule says, oh, you better multiply by y prime. On the other side, derivative of 1 is 0. And so then we have to solve for y prime here. And I'm not going to reduce it quite yet. The 2/16, I'm going to leave that for now. So subtracting the x to the other side, I get 2/16 y prime is equal to -2 over 81 x. And then I'm going to divide by the 2/16 y. So then I get y prime equals -2 over 81 x divided by 2 over 16 y. And that cleans up a little bit because dividing by a fraction is multiplying by the reciprocal. So just a little side arithmetic here. I get -2 over 81 times 16 over 2, and the 2's are going to divide out. So then this gives me -16 over 81 times x over y is the derivative. And then they say here the point 2, 3.9 should be on the graph. And so then if we want to find the slope, we would just plug that in. So our y prime is a function of x and y. And into y prime, we're plugging in 2, 3.9. So then that's going to give me -16 over 81 times, let's see, x goes in the numerator, so that's 2, and 3.9 goes in the denominator. And so that right there is our slope. It looks like it's going to be a messy decimal, so I'd probably leave it, just multiply the numerator, multiply the denominator. So I would say the slope here is negative 32 over whatever 89 times 3.9 is. Let's check that and then graph it. Or 81 times 3.9. 81 times 3.9 is 315.9. So I'm going to say that's my slope. Negative 32 over 315.9. And then I'm going to use the point slope equation to see if that, really looks tangent. Let's scroll down a little more. Point slope form, remember, y minus y1 equals m times x minus x1. So then I get y minus 3.9 should equal negative 32 over 315.9 times x minus 2. And we could solve for y, but we don't need to here. So let's graph that. 315.9, I got that right. All right, so we have x squared, oops, whoa, what'd I do? X squared, there we go, over 81 plus y squared over 16 equals 1. So there's my ellipse, that's a beauty. And then I think tangent to that at the point 2, 3.9, so there's my point on the curve, is the line y minus 3.9. So this is something you should definitely check on when you're taking your test, when you have to get these slopes and tangents. Negative 32 over 315.9 times x minus 2. And that looks like a pretty good tangent on that ellipse. Nice, we did it. All right, next on the list, 25. Let's see, 3 new messages in the chat. Oh, thank you for letting me know about that. If I make my chat bigger, I'll see the new ones. Okay. 22, 25. All right, natural log of the sine of x. So again, another chain rule problem 3, natural log sine of x. So we have y equals 3 times the natural log of the sine. And so we have a chain rule going on, the multiple of 3. I'll try not to lose track of this time. So let's say y prime equals 3 times. And then here I have to identify outer and inner functions. So I always like to do that to be clear. Outer is the natural log of whatever, and the inner is the sine of x. So the chain rule says take the outer prime times the inner prime. So the derivative of the natural log is 1 over whatever was in the parentheses. And in the parentheses happened to be the sine of x. So I kind of didn't need the parentheses, but reminder, in this case, outer prime is 1 over whatever was in the parentheses. And then inner prime is just the cosine of x. So when I multiply that by the cosine of x, because that's the derivative of the inner function, right? Derivative of the outer times the inner. So I get 3 times the cosine of x over the sine of x. And if I wanted to use a little bit of less ink, this would be the cotangent. So I get 3 cotangent of x. So that's the best answer. That answer right there is okay. So good, great. Moving along. We are kicking butt on math problems today. Number, was it 30? Yep. Okay, so we have to determine tangent. Cool. So 9x plus 8 plus 2 times e to the x. So y equals 9x plus 8 plus 2 times e to the x. And we want to know tangent line when x equals what? 0, 10, or the point 0, 10, okay. So x equals 0, y equals 10. So is that true? If I plug in 0, I get 10. Yep, that is true. So y prime, the derivative of 9x is 9. The derivative of 8 is 0, so who cares? And then the derivative of e to the x is e to the x, so it would just be 2 e to the x. And then we want to know what is y prime, where we plug in a 0. And so that would be 9 plus 2 times e to the 0. E to the 0 is 1. 1 times 2 is 2. 9 plus 2 is 11. So the slope seems to be 11 there. So then the tangent line should be y minus y1 equals the slope, right? Y prime is the slope function times x minus x1. So that's just going to give me 11x on that side, add the 10 to the other side, and I get y equals 11x plus 10. Now, on the exam, there's no check my answer button, right? So how do you check that? And the only way to check it is to graph it. So I would whip out Desmos. And if I were taking this test, I would have a whole bunch of Desmos tabs open, probably. So we've got, let's call it f of x is equal to 9x plus 8. So we want to see that our tangent line really is tangent. 2 times e raised to the x. All right, and then we need to adjust our graph so we can see our point of tangency. So maybe I'll just reconfigure this. Let's go from like, let's see, x-axis. Really only need to go from like -1 to 1 should be good enough. And then for y, I think I'd like to see up toward 20. There we go. And then we think that y prime, or f prime, let's call that the derivative, is equal to 9x, 9 plus 2e to the x, right? So that's not the tangent line. That just tells me what the slopes of the tangent line is. So I don't really need to see the derivative. And I think the tangent line is y, or just double check I got the derivative right. No, I don't need to do that. I think it's just y equals 11x plus 10. And my red line looks pretty tangent to the purple one. So I think I'm all right. Cool. All right, moving along. So I did find the correct tangent line. So I think it's y equals 11x plus 10. All right, let's see, back to the chat. What do we got? We got number 14. Yep. All right. And 33, sweet. I think do we have just enough time for those? 14, we have a chain rule. Okay. And then 33, we've got temperature function. Okay, so I think I'll be real quick on those. Oops. (5x plus 2 to the power -4). So we want the derivative with respect to x of 5x, oops, no, I forgot, plus 2. So the outer function is the power -4, so that derivative is -4 times whatever to the power, drop that by 1, -4 minus 1 is -5. Chain rule says leave the inside alone. And multiply by the derivative of the inside, which is just 5. So this one would just be -20, 5x plus 2 to the power -5. All right, temperature problem. So we'll get it set up. I don't know if we'll finish it in time, but maybe. Okay. So what do we know? We've got this temperature function. We want to find the rate of change of the temperature, so that means the derivative. So what's the derivative with respect to x, where x is time in hours of our function t of x? And then we want to plug into that 3 p.m. What is x? X is hours after midnight. So 3 p.m. would be 12 plus 3, so that would be 1,500 hours. So x would be 15. So important, hours after midnight, p.m. So pay attention to if it's a.m. or p.m. there. The derivative, t prime of x, derivative, let's see, what do we got? We have a function within a function. So the derivative of 67 is 0. So I could say this is 0. And the minus 11 just tags along times the cosine's derivative. And then we have the derivative of the inside here. So I have an outer function, which I'm just going to call -11 cosine of whatever. And then I have an inner function of pi over 12 times x minus 2. And the derivative of that, that's just a straight line with slope pi over 12. So pi over 12 is the derivative of the inner. So derivative of the cosine is the negative sign. So I'm going to put in a parentheses and then leave that pi over 12 times x minus 2 alone. All right, so close parentheses, one more. Ooh, that's a lot of parentheses. So that's this one here. Times the derivative of the inner, which is the derivative of the inner function is just pi over 12. So putting that together, I get -11 pi over 12. Oh, times a negative, so that's now positive, right? Because I have these two here. Times the sine of pi over 12 times x minus 2. And then we just want to plug in there, what is t prime of 15? So we plug that into our calculator, 11 pi over 12 times the sine of pi over 12 times 15 minus 2, which is 13. Yeah, so enter that into the calculator and then round that to one decimal place. And that would be what? Degrees Fahrenheit per hour would be the rate of change of the temperature, whatever that in your calculator comes out to be. Make sure you're in radian mode on your calculator. Most calculators like Desmos default to radian mode. So just to see if we're on the same page there in Desmos, what is 11 pi over 12 times the sine of pi over 12 times 15 minus 2, which is 13. I get the temperatures decreasing at that point at about 7.5, or they said go to one decimal place, so just 0.7 degrees. So rounding to one decimal point, I get -0.7 degrees Fahrenheit per hour is the change in temperature. So the temperature is dropping. From whatever it was, and we could calculate whatever it was, but we weren't asked to. All right, we're out of time for fun with math today. Thank you for joining me. Let's see, where's my Zoom screen? Oh, I lost Zoom. Oh, there it is down there. Stop share. Come on. It won't stop. Weird. Can I stop the recording?